TEKS 7C Quadratic Transformation Notes. Okay, so before we begin with each of these new vocabulary words showing you the transformations, I want to go and look at the parent function first. So if we look at the parent function right here, it says y equals x squared. So what I mean by the parent function is that it has no changes to our original vertex form equation. For example, remember our formula for vertex form is y equals a x minus h squared plus k. Notice that our parent function doesn't have a value, doesn't have an h value, or doesn't have a k value. It's completely neutral, meaning h and k are 0 and a is just 1. So before we move on, I want to tell you what each of these a, h, and k does to the problem. So looking at k right here is going to identify a vertical shift. So vertical shift, and remember vertical means up and down, so I'm going to draw an arrow up and down. So if it's positive, it's going to go up, and if it's a negative k, it's going to go down. Okay? H is going to be identified as a horizontal shift. That's pretty easy to remember because H, horizontal, they start with the same letter. And a horizontal shift, remember, is left and right. The only thing that's different between a horizontal shift and a vertical shift is that with vertical shift, the directions made sense with the sign. So if we went up, it was positive. If we went down, it's negative. With a horizontal shift, if we go to the right, that's going to be a negative H. And if we go to the left, it's going to be a positive H. So this is backwards in thinking. Okay. And then real quick, the A value right here is going to tell us multiple things. So it's going to tell us if it is, what type of stretch it is. So what type of stretch. And then it's also going to tell us if it's a reflection. And I'm going to talk more about those when we get to each specific vocabulary word. So wrapping this up, our parent function right here is just the quadratic equation where h and k is 0 and a is 1. So all these graphs that you're going to see on each of these new vocabulary words is going to be the parent function. Okay. Another way we can identify this as the parent function is right here. Notice that our quadratic is going up, so it's a minimum, and it has the vertex right here at 0, 0, which again just confirms that h and k are 0. Okay. So let's go over to the right and look where it says vertical shift down. Okay. Vertical shift down. Remember, vertical shift is our k value. So vertical shift here is our k value. And if it's going down, that means k is going to be negative. And we can see that right here where it says -4. So what that does is it brings the entire graph down 4. So 1, 2, 3, 4. So now instead of being up at 0, 0, our vertex is now at 0, -4. And I'm just going to draw that. So that's the only thing that happened was this graph went down 4. Okay. Let's look at the next one. Let's look at vertical shift up. So find that on your paper. Vertical shift up, right here. Okay, vertical shift up. Remember, vertical shift is again the k value. And up is going to be plus. And we see that right here where it says +1. So that means we're just going to move our vertex up 1, which is right here. Okay. Now let's look for horizontal shift. So horizontal shift right. Let's look at that one first. Horizontal shift right. Remember, horizontal shift is our H value. And then it's always opposite, so right means it's going to be a minus sign. And we see that right here with that -2 inside the parentheses. So that -2 is telling us that our graph is going to move to the right 2. So 1, 2, so right here. So all we did is we shifted our parent function 2 to the right. And that is a horizontal shift right, and remember the sign is always opposite. Okay, let's find horizontal shift left. Right here, right above it. Again, horizontal shift is our H value. Left means plus. Horizontal shift is opposite. And we see that right here in our example where it says +1. So that means we are going to go to the left 1. So to the left 1, right here. That is our new equation. So from our parent function to our new equation, we just moved the graph left 1, a horizontal shift left. Okay. Now let's focus on our A value. So there were two types of stretches. So let's look at the horizontal stretch first. So with a horizontal stretch, our A value is a fraction. So our A value is a fraction between 0 and 1. A fraction between 0 and 1. And what I mean by that is that we can have, we can have a fraction that's greater than 1. So for example, the fraction 5/4 is greater than 1. So this is not what I'm talking about. But in our example, we have the fraction 1/4. And 1/4 is between 0 and 1. It's a fraction, it's a small fraction. So what these fractions do is it makes our graph wider. So makes graph wider. Or another way you can help remember this by saying that fractions equal fat. Remember, when we're talking about fractions, we're talking between 0 and 1, the small fractions, not the improper ones. Okay, so if it makes it fatter, it makes it wider, then it's going to look something like this. Our graph is now wider than our parent graph. It got stretched out. Another way that we could visualize this and to remember that a fraction or a horizontal stretch makes the graph wider is hold your hands together and pretend like you're holding a rubber band. So if we stretch that rubber band horizontally, so left and right, notice as you bring your hands further apart, your rubber band is going to get wider and wider. So it's another way to remember it. Okay, now let's look at vertical stretch. Vertical stretch is another one that deals with the A value. So this is when the A value, the A value is greater than 1. Greater than 1. So 2, 3, 4, so on and so forth, all the way to infinity, greater than 1. It could be a decimal greater than 1. It could be an improper fraction, which is greater than 1. So my example up above, when I said 5/4, this is greater than 1. So this would be an example of a vertical stretch because it's greater than 1. Okay, and when it's greater than 1, this vertical stretch makes our graph narrow. So it makes the graph narrow, or another word for narrow would be skinny. Makes the graph skinny. So again, if we are using that analogy of holding the rubber band, I want you to again put your hands together, but now in a vertical position, so up and down. And I want you to stretch your imaginary rubber band up and down. And notice as you stretch it up, your rubber band will get narrow. It will get skinnier. So that's one way to remember that a vertical stretch where the A value is greater than 1 makes the graph narrower or skinny. Okay, and there's one last thing that deals with the A value, and that is a reflection right here at the bottom, reflection across the x-axis. And you know it's going to be a reflection across the x-axis because of this negative right here. So if the A value is negative, the graph will flip, that's our key word, flip, across the x-axis. So it would look like this. So now instead of a minimum, it's turning into a maximum. It flips across the x-axis. It's a reflection. Okay? And we notice that if we have a negative A value. Okay, so on your guys' assignment today, we're going to use all these vocabulary words, and you're going to be telling me if a specific problem has a reflection, if it has a horizontal stretch, vertical stretch, shifts, anything along those lines. If you have any questions, please feel free to ask me.